About 4.5 billion years ago, a massive cloud of interstellar gas and dust floating in the Milky Way began collapsing inward. The intense friction and gravity forged a swirling solar nebula, with material aggressively colliding and fusing together to form the Sun and its surrounding planets. Building a star system this way requires an exact alignment of cosmic conditions. Across the entire Milky Way, only about 15% of stars manage to host planetary systems of their own. Because we grew up here, it is easy to view the solar system as our quiet, familiar backyard. But the moment you step off Earth, that illusion breaks. The surrounding planets offer a gauntlet of extremes, exposing anything on their surface to conditions that will instantly burn, freeze, crush, or vaporize you. To see how exceedingly lucky we are to exist at all, we have to look past our own atmosphere and investigate the terrifying environments of the 7 other planets we share an orbit with. The 4 planets closest to the Sun are the terrestrial worlds. They are relatively small, made primarily of rocky material, have solid surfaces, and host very few moons. The closest planet to the Sun is Mercury. You might expect a world orbiting just 36 million miles from a star to be constantly boiling, and during the day, temperatures do reach a scorching 800 degrees Fahrenheit. But Mercury has almost no atmosphere to retain that heat. When the Sun sets, the temperature rapidly swings the other way, plummeting to negative 290 degrees in the dark. If we move one orbit further out to Venus, the heat problem actually gets worse. Venus sits further from the Sun than Mercury, yet it boasts thousands of volcanoes and the hottest surface temperatures of any planet in our system. The cause of this extreme heat is a runaway greenhouse effect. Venus is blanketed by a dense atmosphere of carbon dioxide and thick clouds of sulfuric acid. This traps the incoming solar heat, creating an inescapable planetary oven that bakes the surface at nearly 900 degrees Fahrenheit. In the inner solar system, finding solid ground does not grant you safety. It guarantees either a battered, freezing rock or a highly toxic atmospheric inferno. Just past Mars lies the Asteroid Belt, a flat ring of rocky remnants left over from the solar system's chaotic formation. Crossing this boundary takes us far away from the solid terrestrial worlds and into the realm of the Jovian gas giants. In this cross-section, Jupiter is 11 times wider than Earth, yet lacks a solid surface. Descending through the clouds, extreme pressure condenses hydrogen gas into a swirling liquid McHelmut hydrogen ocean. At the rocky core, temperatures spike to 43,000 degrees Fahrenheit, hotter than the Sun. Above that hidden ocean, the upper atmosphere hosts wildly lethal weather. The most prominent storm, the Great Red Spot, is a hurricane at least twice the size of our entire planet, turning with wind speeds up to 270 miles per hour. Jupiter's neighbor, Saturn, trades volatile storms for its signature sprawling ring system. But diving into Saturn's atmosphere is just as deadly. Its upper layers are packed with clouds of ammonia ice that plunge temperatures well below negative 270 degrees Fahrenheit. So the vast majority of the planetary mass in our solar system doesn't exist as walkable terrain. It exists in highly pressurized gaseous and liquid states that would instantly crush and dissolve us. Push past Saturn and the composition of the planets shifts again. Uranus and Neptune are the ice giants. Rather than just gas, the bulk of their mass comes from a dense, freezing fluid mixture of water, methane, and ammonia. At 2.8 billion miles from the Sun, Neptune claims the title of the coldest planet. Temperatures here routinely hit negative 360 degrees Fahrenheit, while fast-moving, dark vortex storms, some as large as planet Earth, tear across the atmosphere for weeks at a time. Continuing past Neptune puts you inside the Kuiper Belt. This massive, flat disk of icy space debris orbits far beyond the major planets. It acts as the birthplace for countless comets and serves as the home for dwarf planets like Pluto, suspended in a permanent deep freeze. If you keep traveling outward, you eventually hit the Oort Cloud. This vast spherical shell of icy fragments marks the definitive edge of the solar system, the final boundary where the Sun's gravitational and physical influence finally stops. When you look at the extreme outer edges, the math becomes clear. The default state of our solar system is a dark, frozen wasteland, completely stripped of the thermal energy needed to sustain biology. To find life, we have to retreat from the freezing outer limits, bypass the crushing gas giants, and return to the inner solar system to look at Earth and our immediate neighbor, Mars. About 3.7 billion years ago, Mars actually held a watery surface and a moist atmosphere. But today, the water is gone. It is a dry, freezing desert with heavily reduced gravity and intense dust storms. Earth thrives because of a highly specific set of variables. We orbit at the exact right distance from our star to keep liquid water flowing. That placement, combined with the precise density of our atmosphere, creates the only environment in the known universe capable of keeping complex life alive. But the margin for error is razor thin. Looking at Venus shows us exactly how quickly a terrestrial world can become uninhabitable when a runaway greenhouse effect destroys the atmospheric balance. We are surrounded by frozen debris fields, acidic ovens, and crushing stormy giants. Our lush environment is a massive cosmic anomaly, a fragile oasis in a highly hostile neighborhood. Our survival depends entirely on our collective ability to understand that delicate balance, to adapt to it, and actively preserve it.